Thank you, Tim. Well, this is a little different talk than the last 9 years I've given a talk. I missed one. I didn't even know it existed that first year. So as Tim said, disruptive technologies and what's happening with our hobby. So disruptive technologies can be several things. They can create a new market, disrupt an existing market, and drastically affect market share of existing companies, improve performance, and reduce cost. So here's some examples from the past. Of course, tubes were replaced by the transistor, and I just learned just recently that microwave ovens are switching over from magnetrons, which are a tube, to LDMOS. And that's probably going to be good for us because now transceivers are using LDMOS and certainly the high power amplifier. So maybe that'll bring the cost down of LDMOS. Another example is digital cameras and Kodak film. Now, Kodak invented the digital camera. You may not know that. The first camera was like 100 pixels by 100 pixels. But they didn't want to cannibalize their film market, so they lost the digital camera world to everybody else, and you can see how well that worked out for them. And then, of course, the iPhone with Apple, that changed the entire cell phone industry. My Motorola brick, you probably maybe had one of those a long time ago, and long time history there. So in our lifetime, what are examples of disruptive technology? I got my general license in 1961. And at that point, the Drake 1A, maybe you've seen it at the swap meet sometime, that was a sideband only receiver that was very small really, sit beside your great big boat anchor AM receiver. That had been out for 4 years. And the KWM2 had been out for 2, kind of beyond my price range when I was 14 years old, or my father's price range. So in my village where I lived, there was one other ham with an M2 and one with a 75A4. So they were all set up for sideband. But a lot of sidebanders didn't like it. You know, if you tuned in a sideband signal on AM receiver, well, it sounded pretty strange, and they called it slop bucket, and this was terrible. But, you know, by the end of the 60s, sideband had really won out. The other thing that's a massively improvement is contest logging. My first contest was while I was in high school, in a multi-2 160-meter contest, and you say, well, why was it multi-2? Well, back then, we only had 2 segments on 160, the lower 25 kilohertz, the upper 25 kilohertz. We had significant power restrictions. I think we could run 50 watts at night. No one would cheat, though. And logging wasn't too bad because we logged a serialized file card, so they were all numbered ahead of time. In this contest we were running, we had to give the serial number. But the problem was dupes. And who had you already worked? So we had one person assigned to this great big piece of paper taped to the wall, and he was supposed to write the calls down in the order of the zones, of course, 1, 2, 3, 4, and I'll keep them in alphabetical order on this piece of paper on the wall. So that was tough, and now it's just amazing what we can do with computerized logging. So the question now is, there a hardware change? There's a really significant hardware change coming. Now, the super heterodyne architecture has been around a long time, and longer than I imagined when I looked it up. Edwin Armstrong, clear back to 1918. So it's been around and is very mature. In 2008, 2 interesting products came through my lab, and one was the K3, and I'm sure there's, how many K3 users got here? All right, lots of you. And how about Perseus? Well, that was only a receiver, but anybody own a Perseus? Okay, a few. It's a direct sampling receiver, but that was the key. It was a receiver. But what was different about it, it didn't have a local oscillator like all the super het transceivers or receivers. It just had a clock, in other words, a time base. So, but that really showed what's going to come down the pike when direct sampling became more common. I'm not sure when the first transceiver came out, but the first one probably of significance was the announcement at Dayton in 2012 of the Flex 6000 series. It didn't ship for like a year and a half, and I didn't get a hold of one from Gerald on loan until January of 2014. Software was pretty primitive back then. It was either 1.0 or 1.1, I'm not sure. And I used it in the CQ Worldwide 160 meter contest. Then at the end of that same year, I ran the ARRL 160 CW contest with better software, 1.3, and then a week later, Actually, the 1.38 was out, but I didn't want to try it, so I did try it in the 10-meter contest. So that was the beginning of my experience with the direct sampling radios. But there was a big difference with the new products because it was proprietary software. As you may remember, the earlier Flex products were open source, and they were used by other companies, and sometimes that didn't go over real well. So anyway, there was a change made, and everything's proprietary now. The other thing that was real different was up until relatively recently, the Flex direct sampling radios had high latency. Now that means the signal comes in the antenna and you don't get to hear it coming out the speaker or your headphones for, in this case, 163 milliseconds, and that's a pretty long time. And so recently they've made a change, and you can pick a trade-off between the shape factor of your DSP filters and the latency. The default's 100 now, still not real fast, but if you go down to like a shape factor of 2.2 or 2.3 or something, you can get it down to about 50. But then the analog radios that we're all familiar with, about 10 milliseconds. So that's quite a difference that the latency still can be an issue. The other main player in the direct sampling transceiver was Apache Anand. I did test a 100D initially. I didn't ever use it on the air. It had a problem with its clock, and it was kind of noisy. So they eventually fixed that, and mostly fixed it in the 100. But the 200D, that was actually had the same clock, but a while later they replaced the clock, and the problem with that went away. So I used that 2 different times, December 2014 and January 2016, again in a 160-meter CW contest. It comes out of India, and they have a nice advantage. They don't have to spend any money developing the software. It's all done for free, open source, mostly hams in the US. I think there may be one in Australia, but Warren, NC0B, he just done most of the software, and it's like, even though it started out with software that really came from Flex, Power SDR, it's like 99% totally new software. So it's really their own software now, but again, open source. And with Warren, I can call him up and say, you know, I ran into this issue, or maybe how about this new feature? And within a week, or maybe days, he'll have it fixed or added a new feature. So this is just astounding how fast Warren cranks out new software or fixes. And the latency has been improved. It was 130 milliseconds for at least a couple years. And now in the last few months, he's changed the way he defines the filters, and the latency is now under 20 milliseconds, which is pretty much in the ballpark of what we're used to with our legacy radios. So let's say early 2016, last year, there were sort of 2 parallel tracks. If you would say the K3 would be an example of the down conversion superhet radio, and there's others, of course, and then the Flex and the Apache were the main people in the direct sampling SDR. And they both have advantages, whether it's the superhet or whether it's the direct sampling. One thing I want to stress is I'll get people call up and they'll say, well, I have this radio and it's on your chart and it says it's 95 dB, and should I trade it in on one that's 99? Well, this is crazy. I mean, on my website, there's a lot of information, and we really have to be reasonable because you don't buy a radio for one number. And for sure, a difference of a few dB is not significant either. Luckily, most of the time, for most of our operating, that an 85 dB radio is fine. I mean, if it wasn't, we'd be stuck with 1 or 2 radios to choose from, but that's not the case. So let's don't go crazy about wanting a 100 dB radio. I don't own a 100 dB radio, so there we have it. What we do need for CW is pretty much an 85 dB radio would be a good point to sort of say, well, I'll say anything that's that or larger, I'll consider that something I want to purchase. And the reason for that really has to do with transmitted bandwidth. On CW, if we have a clean signal, we don't have key clicks because we set the rise time at the wrong value, well, we're only about a KC wide at minus 60 dB. Now, if we just put a rock on the key, our bandwidth is probably 100 hertz or something. But if we're sending hopefully our call, and maybe 599, everybody's 599, right? And then a serial number or ARRL zone or whatever. So if we're about a KC away from a really strong signal, and the rise time is reasonable, like 6 or 7 or 8 milliseconds, we're going to be a good neighbor, we're not going to be bothering people, and we're going to be able to copy. And that's why we can have all the band full of strong signals, and as long as we're away from one by a few hundred hertz or a kilohertz, then the receiver's not limited by something else, but whatever its dynamic range is, or phase noise for that matter, which I'll cover. But now in sideband, it's a different story. The average bandwidth of most of our signals that are being run properly, I'm not saying we have the processing cranked up full clockwise, or we've got a linear and we're driving 100 watts into it and it takes 50 watts a drive. Our normal bandwidth is about 10 kilohertz at minus 60. So that gives you an idea why there's somebody calling CQ test incessantly, and I'm trying to work this multiplier that's 3 kcs away. I'm probably not going to be able to work that guy until the guy shuts up for a moment because of this transmitted splatter of that signal with a standard 13.8 volt PA run properly, not flat top in the amplifier. And this all makes sense that when the upconversion radios came out, maybe the TR7 was the first, but like a Pro 3 is an example of kind of the end of that line. All these radios had a dynamic range of about 70 dB, plus or minus 2 or 3, almost all within that range, because the way they were designed. A real wide 15 or 20 kc upconversion filter, a whole lot of gain, and therefore the dynamic range was limited. So on sideband, we lived with it because most of the time on sideband, the transmitted splatter, just the distortion products of our solid-state PA were the limit. CW wasn't ideal, certainly to de-expedition or something like that. So these direct sampling radios are different, and they actually have distortion products kind of all the time, unlike our radios we're used to. And so Flex said, well, let's test radios so we can test them all the same way. And he said, let's come out with something called IFSS, in interference-free signal strength, that's going to be referenced to band noise, which is kind of different. So when we test a radio normally, we look at the intermod product. That's how we define dynamic range. In other words, you feed in two signals. When the distortion products equal the noise floor, that's how dynamic range was defined in 1975 when the League did it and Ham Radio Magazine. And so it was pretty straightforward, and we just had one number. But when we're going to look at the direct sampling, well, the distortion products are just totally different because at the lower level we get a distortion that is relatively constant. So you can then say, well, okay, I'm going to graph the data of a radio, any kind, a classic radio or a direct sampling, and I'll get a bunch of data points. I can put it in a spreadsheet, and so I can look at the distortion products over signal strength. But then, see, this reason I think this came up was, well, because we can't get rid of the distortion products on the direct sampling radio, if they're below band noise, well, we don't really care. I guess you can say that. But the trouble is, what's band noise? Because that varies all over the map, which we'll see. So here's some information that comes out of your ARRL handbook. It's ITU data. It was taken a while ago. So if you look in the handbook and look at the graph of typical band noise, they have urban, rural, and quiet rural. Now, I think the urban numbers are way too low now. I don't know if you guys mobile, but when I drive through a town, I might as well turn the transceiver off. But the typical rural band noise is very accurate. I've shown my tests to be within 1 or 2 dB of this at my contest station out in the middle of nowhere. So those 160, 80, and 40 numbers are nighttime, and the 20, 15, and 10 are daytime. And you see the difference between 160 and 10 is like over 30 dB. So if we're going to value how a receiver plays reference to band noise, it's like, well, what are we going to have, 6 numbers? So it's kind of a interesting quandary there. How are we going to publish that? So I said, okay, I've never done an IFSS test, and I was lucky enough to have a loaner of a K3S and a 6700 from AA5GI. And I said, well, we've got to have a level playing field here because, for instance, the Flex with the preamp off has drastically less gain than the K3 with the preamp off. Say, well, that's not fair if you're going to look at overload. So I said, okay, let's set the 2 radios up so they've got identical noise floor as though we'd want it on 10 meters. And in that case, that was the K3S with the preamp off and the 6700 with the 20 dB preamp on. And they both had the same minus 135 dBm noise floor. So now we can test it, and it's apples and apples. But then we could also test it the other way, like we want to see what's it going to do on 40 meters. So in that case, with the K3S, which by the way has an attenuator that's either a 5, 10, or a 15, unlike the K3, which just had a 10. So I had the 15 dB attenuator on to compare it to the Flex with the preamp off. And so the noise floors were within 1 dB. One was 118, one was 117. And in that case, they actually flipped at the 6700 came out ahead. So both architectures are fine. They have good dynamic range. They have good phase noise. So we really want to say, what did this graph of how these two completely different architectures compare? Now, we would hope the graph will be relatively smooth. And by the way, when you test a classic radio, a super het radio, it will almost never, I don't think I've ever seen anything that had a really crazy graph of its distortion products, because it's just the way it works. So this is the graph of comparing the Flex on the left, the blue one, and the K3S on the right, and the right is better. And the difference was like 4 or 5 dB. And we say, okay, when are those radios set up as though we'd run them on 10 meters or 12 meters, and maybe even 15 if you're in a quiet location. So if we look at the blue line, they're at an angle, and the 10-meter rural band noise, which is what I measure at my QTH, that at a signal of S9 plus 45 dB, which is pretty strong, maybe the Flex is going to start to show some distortion. At the same time, in that case, the Elecraft, if you go straight down from the red arrow, well, it's not even going to be showing the distortion at quiet rural, which I sometimes see. Now, in my case, we were talking about a lot of times about noise today. When I point my Yagi to the Caribbean, that's where my most noise is. But if I point it to JA, it's amazingly quieter. So band noise really does vary with direction, of course, besides band. Now, here is the opposite setup with the more setup like you'd probably do for 40 meters. In this case, the blue line, it's a little wobbly, but that's the Flex, and it was on the right. So it was ahead by 4 or 5 dB. But look where the distortion would just be not even showing up on the Flex, but in a 40-meter rural noise level at night, the K3 is not going to have any distortion, because if you go straight up from that red arrow at 65 dB over 9, which we don't see too many signals that strong, well, the K3 is doing just fine, and of course the Flex is doing better. But then look at the Flex, has got this sort of wobbly curve down at the left, and that's the reason that we're having issues of how do we test these direct sampling radios, because they do have wobbly distortion characteristics at the lower signal level. So, it's been a challenge to figure out how to really compare things. So those were curves of a 6700, but all the direct sampling radios aren't that well behaved. You would really like a monotonic curve, meaning it doesn't change direction and do funny things. So again, remember then, the super het never has a funny curve in its distortion products. So here's one that had a funny non-monotonic curve. Look at the green one there. And it peaks up and then goes down. And if we're really looking at 20 meters with that blue line there in the middle, it's the red arrow is pointing rural noise. Well, it's really still not much of a problem, because it's peaking up there at about 40 over 9. But if we were in a quiet rural, then that's one of the horizontal lines down near the bottom. So in that case, the distortion products in the direct sampling radio would be a potential problem. Now, there's the worst radio I ever tested with this IFSS method. That is certainly not monotonic. And look where the peak is, S9 plus 8 dB. So that would certainly be a problem. Now, in 20 meters, you'd say, well, most of the time it's okay. But what about 15 meters quiet rural? The left hand of that graph is S7. So we could be in trouble there. So that wouldn't be my choice for a contest radio. By the way, I took all the data, but Adam Farson, who's over here, he did all the graphing for me, and I really appreciate it. Thank you, Adam. Okay. So disruption to our world began in April of 2016. The first quarter of 2016, if you happen to look at my website, there were like 18 superhet radios there that you should be perfectly happy using in a contest. They had 85 dB dynamic range, and then of course were the two brands of direct sampling to choose from. And then Icom, what I say, dropped a grenade into the status quo. The 7300 hit the market at $1,495. And it was a direct sampling radio with knobs. It didn't need a computer to run it. You just took it out of the box, plugged it in, and off you went. So sales went through the roof, and no dealer could keep them in stock in April or May of last year. And actually, there was a mini price war. One of the dealers said, we'll sell it to you a little bit cheaper. I don't remember, it was $50 or $100 cheaper, but they didn't have any. But they could sell you one in June or July, and I don't know how many people did that, but the price war didn't go on very long because if you wanted it, you probably paid the $50. So last year at Dayton, Icom brought 1,000 7300s to their dealers, and every one of them sold out at the Dayton Hamvention last year. So two things were apparent. Hams still like radios with knobs that you don't need a computer. And the other thing was, by summer, or at least fall, the price was down to $1,300. Well, at $1,300, a heck of a lot of hams said, I can try that out. If I don't like it, I can't lose much, and it's not going to break the bank and cause problems at home. And the sales just kept rolling on. So I got a hold of one, thanks to Tim, and tested it before CTU last year and ran it through the laboratory. And the numbers were good. With some limitations. I probably wouldn't be my first choice for field day unless I had some bandpass filters because the front end's not real sharp. For instance, if you have it on 20 meters and then you see what frequency are we down 10 dB? In other words, the front end selectivity is such, we're down 10 dB on 40 meters and then on 17 meters. So it's not a very sharp front end. So you can see field day would need some help. But I didn't really have a chance to do anything until at least the contest I work starts with CQ Worldwide. So that's where I had to really see, okay, how's this thing play? So here's the contest that I ran, the 7300, in the 2016-2017 contest season. Now, the first one was CQ Worldwide and 10 meters only. And you said, why was that? Well, I have 3 operating positions, and I change bands by changing chairs. So I had the 7300, which was the best receiver I had for 10 meters. It was the most sensitive, noise reduction, things I liked. So I left it on 10, and I had another transceiver on 15, another one on 20. And then, of course, at night I switched them. The ARRL 160 CW, the 10-meter contest the next weekend on both sideband and CW, and I'll cover that in a little more detail. That was an interesting contest. But W1BB, that's interesting because, you send out your grid square for the W1BB contest, so your VHFers are used to that, but I think that's the only HF contest, at least I'm aware of, where you send out your grid square. And then CQ Worldwide 160 CW, again in January, you say, why'd I run it for 6 hours on Sunday? Well, I was running another direct sampling radio with some extra knobs, and it was kind of frustrating, and at 1:30 in the morning on Sunday, I unhooked it and hooked the Icom back up, and I was a happy camper. I used ran it in the 1010 Winter CQ contest, QSO party, and then, of course, the ARRL DX, again on 10 meters because this is the way I operate with 3 different operating positions. So how did it perform? Well, I was really amazed, actually. I mean, Icom says it's an entry-level radio, which to me meant, well, kind of like a 718. No. I was just amazed. I could live with it as my only radio. Now, I don't want to do that, but I could. So how many of you work 160 CW contests? All right, enough for you to know that there's a lot of QRM. I would say stations are every few hundred hertz from the low end of the band up to like 1860 to 1880. So it's a busy contest. And I'm an S&P operator on CW. I can't run. I'm not that good at CW. And it takes me 2 to 3 hours to go from 1800 to 1880. I got to tune every signal in, and if I hear him and I haven't worked him, I can work him. I can work anything I can hear. I don't have any fancy beverage antennas. And if I haven't worked him, I work him. If I have, I go on. But it just takes me forever, and I'm totally non-assisted. I don't look at any computers or anything like that. The other extreme was the next weekend's 10-meter contest. Conditions were, well, shall I say, terrible. A lot of the time there wasn't a single sideband signal that I could hear from Colorado. I don't know what it was like in the East Coast or something, but it was a struggle. So I spent a lot of time on CW at the low end of the band, and I had the preamp 2 on. It was like, we're talking about weak signal reception here. There was one short skip opening, probably E-skip, I suppose. It was open to the Pacific Northwest. I was working Oregon and Washington for the most part, like about 80% of the stations. And I was really surprised because as bad as the conditions were, I figured a lot of people would have thrown in the towel. Somebody must have spotted me because in 45 minutes during this one opening, I worked 94 stations. So like that's one every 30 seconds. And I was just amazed at all these W7s that were still going at it. So that was fun. But it came and went and back to the CW again. So how do the features work? Well, you can select your default bandwidths by mode. So for CW, you can pick like 800, 500, 250, whatever you like, and set it, and then you can easily just touchscreen, bong, you got another bandwidth. Or on sideband, you can pick, I happen to pick 2.1, 2.4, 3.1, 2.4, and 1.8, but you can pick anything you want. So it's very flexible. The filter selectivity is excellent. So that worked out well. Now the limitation is it's not a great QSK radio. I worked at 26 words a minute, semi-break-in. It will not do QSK at 30 words a minute at all. It's got 2 relays in it. One's for the TR switch and one's for the key of the linear. So when we see the next version, which maybe you saw the prototype out there this morning, the 7610, we'll hope it does away with that. I used N1MM Plus. It worked perfectly. There wasn't the slightest problem. One thing that was a surprise to me, I have a Pro 3 that I bought like 10 years ago. And for me, if I'm running the sideband filters on sharp, I don't like the audio. It's harsh. It's tiring. In past presentations, I've talked about contest fatigue. I don't like the radio to make me tired. I mean, it's tiring enough to be on the air as long as you can stand it with all the QRM and noise and static or whatever without the radio making it worse. So I could never operate the Pro 3 on sharp on sideband, but the 7300's fine. And, you know, they're saying Icom use the same code, but maybe it's the processing power. I don't know what the difference is, but it's just fine. One thing, I've never been a noise reduction fan. On sideband, it always sounded like, unless if I set it on 1, maybe it would help. If I set it higher than that, it sounded like a bad cell phone call. You know how they sound. When on CW, band noise would sound chunky. So I just didn't like noise reduction. I never used it. Well, I ran noise reduction on 160, on 3 out of 10. The whole time, and it really took the edge, and it really helped from being tired. On 10 meters, I ran it on 3 most of the time, and sometimes 4 on CW. It really took the edge off the noise, so now suddenly I'm a believer in noise reduction. It has the quarter tuning speed that I guess Icom's had for a while, and I like that, good tuning speed. And here was the surprise. It had a latency of 10 milliseconds or less. So that's just like your analog radios. Remember that the default now in the Flex is 100, and Anand used to be 130, and it's now under 20. So latency for you really good CW ops, I think, would be an issue because you really don't want to hear it out your earphones about, over 100 milliseconds later. The spectrum scope is small, but it's very sharp, and I never felt I couldn't find something on the band because of that. Bigger would be nice, but it isn't. And I was running high power class and all those, just to let you know, the Alpha 89, which is a pin diode QSK amp, and the Icom 1000. That's what I use the whole time. One note though, and I hope Icom will fix this, there's a little tail on key up where the linear gets turned off before all the RF is quit. And you can hot switch an alpha 89A, alpha 87A. It isn't going to blow it, but it'll cause key clicks. So my two amplifiers happen to the 89 and the Icom 1000. They won't switch back to receive until all the RF's gone. So one would think that this could be fixed in firmware. The league mentioned it in their review. Adams mentioned it and told Icom about it. I certainly mentioned it. So this could be fixed, and we really need them to fix that. So here's some amazing sales comparisons. From April of 2016 through January of this year, Icom sold over 10,000 radios worldwide. In the US and Canada, over 5,000, and in Europe, over 3,000. I was sitting at DIA, Denver International Airport, on Wednesday, looking at my email, and there was a post on the Yahoo 7300 reflector on someone who bought a new 7300 on May 11th. The serial number was, well, it was for the US and Canada, starts with like 020, but then it was 9230. So that means over 8,200 radios have been sold in US and Canada since it came out 13 months ago. To put that in perspective, the K3, and look at all the K3 owners, it took Elecraft 10 years to sell 10,000 radios. And this is just, off the chart. So the question is this going to be a major architectural change with the direct sampling and a radio with knobs? Well, we don't know that right now. But in another year, or certainly 2 years, we'll have an idea if things are just all of a sudden a shift. And so we actually saw the next version here this morning, and you'll see it tomorrow. So what's changed in the last couple of years? Now, when we test radios, we, of course, have been knowing about dynamic range for a long time. And then sort of the testing changed. And I have a little bit of a squabble with the league on that. But they also, since 2013, have been really having a chart that clearly shows what reciprocal mixing dynamic range means. That's phase noise. All of our synthesized radios, ever since we got rid of, Collins, Drake type radios, that the synthesizer is noisy. And therefore, there is often the limitation is the synthesizer. So right now, the Icom 7851 and the K3S with the new synthesizer, that's not the case, but most all the others, it is. And if you have a K3, buy your $200 upgrade for the synthesizer. It's really worth it. Now, the thing is, the direct sampling radios have changed this because if you put a decent clock in a direct sampling radio, you're not going to have a phase noise problem either. So it made it easy, where only two radios in the super het world have really been able to pull that off. One thing that's all over the map, though, on the direct sampling radios is the front end. As I mentioned a moment ago, the 7300 is only down, if you're on 20, is only down 10 dB on 40 and only down 10 dB on 17. The low-end Flex 6300, it has a high-pass filter to kill off the broadcast band. It has a low-pass filter to kill off everything above 6 meters, but otherwise it's wide open. So if you had a field day situation with no band pass filters and you were trying to operate on several bands at once, that would not work out well either. So that's the thing that at the moment is quite variable from model to model. That could even be a problem, if you've got a neighbor a mile away that's on the air. So what's coming down the pike? Well, the 7610 is, the next level up, and it has a tracking preselector, but I don't know anything about the curves. So, how good is it? We don't know, but we will soon, I'm sure. It's dual ADC, so it's a dual receiver, just like if you set up your K3 for dual receive, which is really nice for contesting, and particularly de-expeditions. Every de-expedition runs split. So I really like to have a dual receive if possible, or dual watch is what they maybe call it. Don't know about the TR switching. Hopefully it's solid state, so you QSK guys can be running at 40 words a minute and things like that. The other thing that is now out there for the last month or so is the Apache Anand 8000 DLE. I don't know why they had to put so many letters after it, but that's what it is. It's supposed to have better phase noise, and the 200 wasn't bad once they replaced the clock. It's a 200 watt rig, although, you know, if you're driving an amp, who cares, but it's a 200 watt rig. LD MOS, and maybe the LD MOS prices will be cheaper due to the microwave ovens use them now. It does have an internal DC to DC converter, which is kind of nice. You can go buy an Astron 13.8 volt power supply rated at 50 watts, 50 amps ICAS, and run your rig, the 8000 DLE. Now, why is that important? Well, for instance, for 3 years I had a TS990S, and it took an EMP whack from a nearby lightning strike that blew up all sorts of things. And I thought it was the power supply. Well, it didn't end up being the power supply, but I did find out that the power supply for the Kenwood is $900. And one ham did have to send it in that I know of to get Kenwood to fix it, and parts and labor was $1,350. Plus shipping both ways, which in my case was $150 each way. So power supplies can be an issue. So if you can get one for $200, I'll be happy with that. One thing that's really amazing that the software that Warren and our NC0B has written for the Apache products is called Pure Signal. This uses pre-distortion, and this is something the broadcast industry has had for some time, but they're kind of lucky. They're on one frequency with one power. And if you do pre-distortion, you have to sample the output of the transceiver or the output of the amplifier and feed it back into the radio and cancel out the distortion products. Well, the typical radio today, your distortion products, as I mentioned, that's the limit for a sideband, is down about 30 dB from the two tones, or 36 dB if you count it the way the league does or the OEMs, because it makes the numbers bigger. But if you measure on a spectrum scope, you normally just measure versus the two tones. So typical is 30 dB, and the Apache with pure signal was 70. That's even better than Class A. Now, a friend of mine, unfortunately he's now SK, W6XX, had a phenomenally clean signal. He ran his Mark V at Class A. He had a really clean 8877 amplifier, and his distortion products were down better than 40 dB for the transceiver and 40 dB including the amplifier. And then now we're talking about 70 dB. What if everybody was that clean and didn't decide to have shoulders to keep the people away? Wouldn't that be nice? So here's some measurements. This is not just what theory says that it's going to be. Of course, Warren's measured it at minus 70 or better. Paul, W9AC, and he's well known in your amp reflector, and for LQ, they've all measured it and better than, like, you know, minus 73, minus 74. I just talked to W2GOR over the weekend. He was running his 8000 and with an OM power amplifier, and he said he measured it, the output of the amp with the pre-distortion and his sampling device, down 70 dB. So this is what's possible in the future if this gets picked up. Now, this is an interesting thing. I don't know what it means. You know, Elecraft announced the new KPA 1500, and it has a built-in coupler. And I'm not sure they put the coupler in there so you could hook it up to your Apache 8000. So if that's not the case, maybe this implies something, but maybe we'll find out. So the transceivers we have now, well, we've got lots of super hits that will do well. Oh, by the way, Warren, that's written all this software, he's going to give a talk tomorrow at the Tapper Forum, the Tapper Forum, 9 o'clock tomorrow morning. So if you're interested in talking to him about his software, go see Warren tomorrow. Okay, so we've got, if you look at my website, there's at least 18 transceivers that you should be perfectly happy running in a contest that are standard super hits. And then we've got at least 6 models of Flex and Apache that are all 100 watts and more. So you've got a lot of selections there. And the SDRs can run under Windows and now even iOS for the Flex product. We've got the 8000 is shipping. When I wrote this initially, it wasn't, but now it's been out for at least a month, and I'm running to them on the air. The other thing that's kind of interesting was Maestro, which is a Flex product that is really a tablet with knobs. It makes the user interface better. So that's an interesting variation instead of having to use a mouse, which I found kind of clumsy in a contest. Of course, the 7300 is the only, at the moment, standalone radio that's direct sampling with knobs, with a small display, but it works fine. And hopefully we'll get to see the 7610 in July or whenever it really ships, probably sometime midsummer. So how will this shake out in the long run? I don't know. Major chain takes time. Up conversion only radios are basically gone. I mean, they lasted for about 20 years or so, TR7 up through the Pro 3 or the 7700 and other brands. I won't buy a radio today that doesn't have a band scope or the capability of a band scope. And I never thought much of waterfall because I'm a techie guy. I'm used to looking at spectrum analyzers, so I liked the spectrum scope. But then the 7300 had this waterfall, and after running 7 contests, I kind of like a waterfall. And if you have a 590 SG, for instance, it's got a band scope port, which this 590S didn't have. And you can hook a dongle up to it like a SDR Play or a Perseus or whatever you've got. So you can get a band scope on that. In the long run, you know, pre-selectors went away. If there's actually some young enough guys here that never heard of Drake or Collins, we all had pre-selectors, but, you know, they were mechanical, and you had to align them, and they made the radio bigger. And so they went away for lots of reasons, including you didn't have general coverage with a down conversion radio, well, a classic radio anyway. And so it was cheaper to go to up conversion, but it didn't maintain the level of performance that we expected. So up conversion is basically gone, except for the 7851, because all the other radios just didn't have the performance level we needed for a CW pileup, a CW contest, a DXpedition. So what will we see in the next year or two? Will the SDR prevail? Well, obviously, there's nothing wrong with what we've been using all these years. We've got the K3S and the 7851 were absolutely top performers. But cost may be an issue. Maybe that'll be the driving factor. Who knows? The K3S, if you buy it factory built and you put in a modest number of options, it's about a $300 radio now. And if you put a band scope on it, which I would have to have a band scope, and you had a second receiver, you're up over $5,000. So it's not inexpensive. And then, of course, the 7851's over $13,000. So significant money there. Another thing that people have said, well, I think that the remote operation is going to be bigger in the future because we've got so much noise locally. If we're in town, maybe remote would be a big deal. Maybe your club will have a remote station. But, you know, you can do remote with anything. Icom has remote software. Kenwood has remote software. Not sure what Yaesu has. But we can remote about anything. So that may not be significant in deciding which way to go. Will most people want a direct sampling radio with knobs? Or maybe the computer's just fine. That's a personal choice and really doesn't have to do with how the radio performs. It's more of a user interface issue, and it's what you like. So next year will be interesting. What we don't know is this: has the 7300 been a one-time anomaly? I mean, they've probably sold 13,000 radios now, and in 1 year approximately. That's just amazing. Or is this beginning of just a phenomenal shift within a year or two? At the same time, you can get really good performance with, like the 590 SG. It's under $1,300. How many know N2IC as a contester? This guy wins contests, and he's running a pair of 590s. One's a 590, one's an S, and one's an SG, and he runs SO2R, and obviously he really knows what he's doing. Of course, he does many contests a year. So it isn't like you can't do just fine with the other architecture that we've had all these years. One thing that's really done with the prices of radios today that perform really well, you know, $1,300 or less, is it's affected the used market. It's really cratered some of the older equipment. I think I paid $3,000 for my Pro 3, and I probably can't sell it today for $1,200. But at the same time, if your budget's limited, now maybe is the time to look on QTH.com or someplace and say, I've always wanted that radio. I want to replace something that's really old, and I can buy something for $800. So there's a lot of options there, whether it's new or used. And and enjoy the contesting with whatever fits in your budget. Here's just a link that's in your book for contest university presentations from the past. And we're missing 1 year, but we got a lot of them there. And then the bottom one is just me, that somebody saved that. So there's the interesting thing. Where will we be in another year? I don't know, but it's been a fun time here.